According to the 2002 National Electrical Code, NEC, the server's entrance cable must be protected by conduit from the point of attachment to the building to the meter, as per NEC section 230.6. Let's explore some options and recommendations to address a service entrance cable that is not up to code. Option 1 involves installing conduit. This is often the most direct and code-compliant option. The recommendation is to run conduit from the point of attachment at the front peak of the house, through the attic, and back outside to the meter. This method provides the best physical protection for the service entrance cable. Option 2 involves applying a protective covering. This option might be acceptable if the cable is in good condition and not exposed to physical damage. This involves installing a protective covering, such as metal or plastic raceway, from the meter to under the eave. It's important to note that this option may not be acceptable to all inspectors, as it does not fully protect the cable as rigorously as required by the code. Option 3 involves relocating the meter and installing a feeder. This is a more expensive and potentially invasive option. This approach entails installing the meter on the front of the house and running a feeder to the existing panel. While this option ensures compliance with the code, it might not be the most aesthetically desirable. Considering inspection considerations, all three options could potentially pass inspection if executed properly. The inspector will primarily focus on proper conduit installation or the correct application of a protective covering. If you choose option 2, it's critical to have a discussion with the inspector to ensure it will be accepted before proceeding. Based on the code requirements and typical preferences, the most reliable and code-compliant option is to install conduit from the point of attachment to the meter. This method offers the best protection for the cable and is likely to be approved by all inspectors. Now, let's delve deeper into the specifics of each option, providing more detail and clarity. When considering option 1, installing conduit, there are several factors to take into account. Firstly, the type of conduit to use. Common choices include rigid metal conduit, RMC, intermediate metal conduit, IMC, electrical metallic tubing, EMT, and rigid polyvinyl chloride conduit, rigid PVC. The selection depends on local codes, environmental conditions, and personal preferences. Rigid metal conduit offers the highest level of physical protection, while EMT is lighter and easier to work with. Rigid PVC is suitable for underground or corrosive environments. Secondly, proper grounding is essential. The conduit must be properly grounded to ensure safety and prevent electrical hazards. This typically involves connecting the conduit to the grounding electrode system of the building. Thirdly, the use of appropriate fittings and connectors. Use only fittings and connectors that are listed for the type of conduit being used. Ensure that all connections are tight and secure to prevent moisture from entering the conduit. Fourthly, consider the bending of conduit. If the conduit run requires bends, use a conduit bender to create smooth, gradual bends. Avoid sharp bends, as they can damage the cable and make it difficult to pull through the conduit. Fifthly, weatherproofing the conduit. If any portion of the conduit run is exposed to the weather, use weatherproof fittings and sealants to prevent moisture from entering the conduit. Sixthly, supporting the conduit. Properly support the conduit at regular intervals using conduit clamps or straps. This will prevent the conduit from sagging or becoming damaged. When moving on to option 2, protective covering, the consideration shifts slightly. Firstly, select the appropriate covering. Metal or plastic raceway are common choices for providing a protective covering for service entrance cables. The raceway should be sized appropriately for the cable and should be listed for outdoor use. Secondly, consider the condition of the existing cable. Before installing a protective covering, carefully inspect the existing cable for any signs of damage or deterioration. If the cable is damaged, it should be replaced before installing the covering. Thirdly, proper installation is crucial. Install the protective covering in accordance with the manufacturer's instructions and all applicable codes. Ensure that the covering is securely attached to the building and provides adequate protection for the cable. Fourthly, sealing the ends of the covering. Seal the ends of the protective covering to prevent moisture and debris from entering. This can be done using duct seal, electrical tape, or other suitable sealing materials. Fifthly, inspect regularly. Periodically inspect the protective covering for any signs of damage or deterioration. Repair or replace the covering as needed to ensure that the cable remains adequately protected. When considering option 3, relocate the meter and install a feeder, there are significant implications. Firstly, coordination with the utility company is mandatory. Relocating the meter requires coordination with the local utility company. They will need to disconnect and reconnect the service, and they may have specific requirements for the new meter location. Secondly, selecting a suitable location for the meter. Choose a location for the new meter that is easily accessible for reading and maintenance. The location should also be protected from physical damage and environmental hazards. Thirdly, installing the new feeder. Install a new feeder cable from the new meter location to the existing electrical panel. The feeder cable should be sized appropriately for the load and should be installed in accordance with all applicable codes. Fourthly, grounding the new meter. Ground the new meter in accordance with the utility company's requirements and all applicable codes. This typically involves connecting the meter to the grounding electrode system of the building. Fifthly, inspection and approval are required. After the meter has been relocated and the feeder has been installed, have the work inspected by a qualified electrical inspector. The inspector will ensure that the work has been done in accordance with all applicable codes and that the installation is safe. Now, some additional considerations are worth noting. Firstly, permits are often required. Check with the local building department to determine if a permit is required for any of the proposed work. Do not start any work until you have obtained the necessary permits. Secondly, safety is paramount. Always turn off the power to the service entrance cable before starting any work. Use appropriate personal protective equipment, PPE, such as gloves, safety glasses, and a hard hat. If you are not comfortable working with electricity, hire a qualified electrician to do the work. Thirdly, documentation is valuable. Keep detailed records of all work that is done, including permits, inspections, and materials used. This documentation may be helpful in the future if you need to make repairs or modifications to the electrical system. Fourthly, future expansion considerations. When upgrading the service entrance cable, consider whether you may need to increase the size of the service in the future. If you anticipate adding more electrical loads, such as an electric vehicle charger or a new air conditioner, it may be wise to install a larger service now to avoid having to upgrade it again later. Fifthly, professional consultation is advised. If you are unsure about any aspect of upgrading the service entrance cable, consult with a qualified electrician or electrical engineer. They can provide expert advice and ensure that the work is done safely and in accordance with all applicable codes. When discussing conduit types in more detail, it's crucial to understand their specific applications and requirements. Firstly, rigid metal conduit, or RMC, is a heavy-gauge steel conduit that provides excellent physical protection for conductors. It is typically used in areas where the conduit is likely to be exposed to physical damage, such as in industrial settings or along roadways. RMC requires specialized tools for cutting and threading, and it is relatively expensive compared to other types of conduit. Secondly, intermediate metal conduit, or IMC, is a lighter gauge steel conduit that offers similar protection to RMC but is easier to work with. It is commonly used in commercial and industrial applications where a high level of physical protection is required but the weight and cost of RMC are not justified. Thirdly, electrical metallic tubing, or EMT, is a thin-walled steel conduit that is commonly used in residential and commercial applications. It is lightweight, easy to bend, and relatively inexpensive. EMT is not suitable for use in areas where it is likely to be exposed to physical damage, but it provides adequate protection for conductors in most indoor environments. Fourthly, rigid polyvinyl chloride conduit, or rigid PVC, is a non-metallic conduit that is resistant to corrosion and chemicals. It is commonly used in underground applications and in areas where the conduit is exposed to moisture or corrosive substances. Rigid PVC is lightweight and easy to install, but it is not as strong as metal conduit and may require additional support. When talking about grounding, several key aspects are worth noting. Firstly, the purpose of grounding is to provide a low impedance path for fault current to return to the source. This helps to trip circuit breakers or fuses quickly, preventing electrical shock and minimizing damage to equipment. Secondly, the grounding electrode system typically consists of a ground rod, a metal water pipe, or a concrete encased electrode, also known as a U for ground. The grounding electrode must be properly connected to the building's electrical system to ensure effective grounding. Thirdly, the grounding conductor must be sized appropriately for the size of the service entrance conductors. The grounding conductor should be made of copper or other approved material and should be protected from physical damage. Fourthly, all metal enclosures, such as electrical panels, junction boxes, and conduit, must be properly grounded. This helps to prevent voltage from appearing on the enclosures, which could create a shock hazard. Fifthly, regular inspection and testing of the grounding system are essential to ensure that it is functioning properly. The grounding system should be inspected for any signs of damage or corrosion, and it should be tested to verify that it is providing a low impedance path to ground. Now, let's address fittings and connectors more thoroughly. Firstly, fittings and connectors are used to join sections of conduit together to connect conduit to electrical boxes or enclosures and to provide a means of terminating conductors. It is essential to use only fittings and connectors that are listed for the type of conduit being used and that are suitable for the environment in which they are installed. Secondly, compression fittings are commonly used with ENT conduit. They provide a secure, watertight connection without the need for threading. Compression fittings are easy to install and are relatively inexpensive. Thirdly, threaded fittings are commonly used with RMC and IMC conduit. They provide a strong, mechanically sound connection but require specialized tools for threading the conduits. Fourthly, set screw fittings are sometimes used with EMT conduit, but they are not as reliable as compression fittings and are not recommended for use in wet locations. Fifthly, liquid-tight fittings are used to provide a watertight seal where conduit enters an electrical box or enclosure. They are commonly used in outdoor applications or in areas where the equipment is exposed to moisture. When considering bending conduit, some tips and best practices are worth mentioning. Firstly, use a conduit bender that is designed for the type and size of conduit being used. Using the wrong bender can damage the conduit or result in an improper bend. Secondly, follow the manufacturer's instructions for using the conduit bender. Different benders have different procedures, and it is important to follow the instructions carefully to achieve the desired results. Thirdly, make gradual bends to avoid kinking or damaging the conduit. The radius of the bend should be at least 6 times the diameter of the conduit. Fourthly, avoid bending conduit in multiple planes. If the conduit run requires bends in more than one plane, use a series of simple bends rather than trying to make a complex bend. Fifthly, inspect the bend carefully after it has been made to ensure that it is smooth and free of kinks or damage. Damaged conduit should not be used. When discussing weatherproofing considerations, a few key points should be emphasized. Firstly, use weatherproof fittings and connectors to prevent moisture from entering the conduit system. Weatherproof fittings are designed to seal out moisture and are typically made of corrosion-resistant materials. Secondly, seal any openings in the conduit system to prevent moisture from entering. This can be done using duct seal, electrical tape, or other suitable sealing materials. Thirdly, use conduit that is listed for outdoor use. Some types of conduit are not suitable for use in wet locations and may corrode or deteriorate over time. Fourthly, protect the conduit from direct sunlight. Prolonged exposure to sunlight can cause some types of conduit to become brittle or discolored. Fifthly, inspect the conduit system regularly for any signs of damage or deterioration. Repair or replace any damaged components promptly to prevent moisture from entering the system. When focusing on supporting the conduit, some guidelines should be followed. Firstly, support the conduit at regular intervals to prevent it from sagging or becoming damaged. The spacing between supports should not exceed the maximum spacing specified in the National Electrical Code. Secondly, use conduit clamps or straps that are designed for the type and size of conduit being used. The clamps or straps should be securely attached to the building structure. Thirdly, support the conduit at all changes in direction and at all points where it enters or exits an electrical box or enclosure. This will help to prevent stress on the conduit and ensure that it remains properly supported. Fourthly, use multiple supports when running conduit horizontally. This will help to distribute the weight of the conduit and prevent it from sagging. Fifthly, inspect the conduit supports regularly to ensure that they are in good condition and that the conduit is properly supported. Replace any damaged or missing supports promptly. When talking about selecting an appropriate covering, several factors should be considered. Firstly, choose a covering that is sized appropriately for the cable being protected. The covering should be large enough to accommodate the cable without putting undue stress on it. Secondly, choose a covering that is listed for outdoor use. The covering should be made of materials that are resistant to weathering and corrosion. Thirdly, choose a covering that provides adequate physical protection for the cable. The covering should be strong enough to withstand the expected level of physical abuse. Fourthly, choose a covering that is easy to install and maintain. The covering should be designed for easy access to the cable for inspection and maintenance. Fifthly, consider the aesthetic appearance of the covering. The covering should blend in with the surrounding environment and should not be an eyesore. When considering the condition of the existing cable, several inspection points are valuable. Firstly, check the cable for any signs of physical damage such as cuts, abrasions, or cracks. Damaged cable should be replaced. Secondly, check the cable for any signs of deterioration such as discoloration, brittleness, or swelling. Deteriorated cable should be replaced. Thirdly, check the cable for any signs of overheating, such as melted insulation or charred conductors. Overheated cable should be replaced. Fourthly, check the cable connections to ensure that they are tight and secure. Loose connections can cause overheating and can lead to electrical problems. Fifthly, if there is any doubt about the condition of the cable, it should be inspected by a qualified electrician.